is we're going to make a little XY chart. And if you want to write next to it, just remind yourself that this is your angle, and then the Y value is the actual value that you get. And we could pick lots of points. We could pick every angle around the unit circle if we wanted to. But maybe let's just pick a few, maybe some ones that aren't so bad to do, like 0. I'm going to go radians here, right? I'm going to show my work over here. If I plug in 0 there, what is the sign of 0? Again, these are things you got to know from chapter 4, part 1. Yes, like if I plug in 0 for x, doesn't that make that find what is the sign of 0 radians? Right? So what is the sign of 0? Sign is which one? The x or the y? Sign is the y. Think about my little unit circle up here. What's that ordered pair there? 1, 0. So what's the y coordinate? 0. Right? We got to know these. When we have a test for this part of the chapter, guess what? There's going to be a calculator part and a no calculator part again. You got to know your trig values. I'm not going to pick 1. I don't know what the sign of 1 radian is, and I don't want to just graph a bunch of decimals. I could, but let's pick angles that we know, like pi 6. If I plug pi 6 in there, what do I get? What is the sign of pi 6? Oh, 1/2. That was not so bad. We're going to pick a lot on this one. In the future, we're not going to pick so many. But I'm going to go ahead and pick the next one. What's the next angle on my unit circle? Or, well, we can pick either one. We can pick pi 4th or pi 3rd. You decide. Both of them are going to be decimals. Let's just go pi 4th then. What is the sign of pi 4th? Square root of 2 over 2. When I graph that, I'm going to just graph it as decimal. Which I think, if I remember correctly, is like 1.71. Oh, no, 0.707. So that's like 0.71. Pi 3rds is going to be the square root of 3 over 2. I don't really want to graph another decimal, so let's just kind of skip that one. And let's go to pi halves. I like pi halves. Because pi halves is up here. And what's the sign of pi halves? Yeah, the y coordinate up there is 1. The nice thing is we should be able to use these values and what we know about the second quadrant to keep going here. What's the next one you want to pick? If we keep going around our unit circle, what's the next angle up here? 2 pi 3rds. Well, we didn't pick the 3rds up here, so let's skip that one again. You can pick it if you want. I'm just trying to save some time. 3 pi 4ths. Let's pick that one. And here's what's really nice. In quadrant 2, is sign positive or negative? So is it going to be the same as what pi 4ths was? Yeah, so it's still going to be square root of 2 over 2, which means I already know it's 0.71. And if I go and pick the next one, the pi 6th one over there, what's that going to be? 5 pi 6? And also in quadrant 2, is that one going to be the same? Which would be 1/2. And then I pick pi. And what is the sign of pi? What's the y coordinate over there? 0. Let's just pick one in between. Like, pi's a good one. 3 pi halves is a good one, right? Let's skip to that one. What's the sign of 3 pi halves? -1. That would be down here. Maybe we should pick one number in between pi and 3 pi halves. Which one do you want to pick? Yeah, I would pick the 6th one because it was just 1/2. So if I pick 7 pi 6 in quadrant 3, is that going to be a positive 1/2 or a negative 1/2? Let's go all the way around the circle. So we want to really get back to 2 pi. We're almost there. Slacking off towards the end. So let's pick 2 pi, and what would be the 6 in between 3 pi halves and 2 pi? 11 pi 6. It's also going to be negative 1/2 because sign is negative down there. And what is going to be the sign of 2 pi? 0. And we're going to talk about this again when we graph it, but once I've gone around the circle, are my numbers just going to keep repeating themselves over and over and over again? That's the idea of sine and cosine. They're periodic functions. They just keep repeating themselves once you complete that entire period of the circle. So think about when you graph this. Your x-axis is not going to be normal, 1, 2, 3, 4, right? Our x-axis is going to have angles on it. I like to break it up to my period here. So my end point is going to be 2 pi. And we're not going to make every mark on here. We'll kind of wing it a little bit. But if I make the end of my graph 2 pi, what's halfway in between 0 and 2 pi going to be? Half of 2 pi is pi. Do you agree with that? And if I broke that in half, what's halfway between 0 and pi? Pi halves. And halfway between pi and 2 pi, 3 pi halves. We have lots of other angles on here, and we're going to kind of sketch them in here, but there's no need, like, you need to make your graph go in equal increments, so I think those are good ones to pick. There's also a negative side over here, and we'll talk about that in a minute. But could I do the same thing that's here, and then put it over here, only make them negative angles? We haven't done a lot of negative angles, but I could make this negative 2 pi, so halfway in the middle would be negative pi, negative pi halves, and negative 3 pi halves. And your y-axis, you have some options here also, but what's the biggest and the smallest value that I ever get on my y values over here? One is my biggest, right? Remember we talked about that. Sine and cosine are never going to be bigger than 1 and never smaller than negative 1. So you can make like 7 marks on your y-axis if you want, but I'm just going to make 1 right here. I'm going to make this 1. I'm going to try to go down about the same and make this negative 1. And now I just want to sketch a few of these points so you can get an idea of what sine looks like. We spent a lot of time first semester talking about parent graphs, parabolas, and square root functions and things you should recognize. We're going to add sine to that list after the next few days. So let's plot a few of these. At 0, it's at 0. I'm going to skip these decimals for just a minute, go down to the other nice one. At pi halves, it's at 1. So at pi halves, it goes all the way up here. Where would pi fourths be in relationship to 0 and pi halves? Yes, but on the x-axis, you agree pi fourths is halfway in the middle? So halfway in between 0 and pi halves would be my pi fourths. And it's 0.7, which is about 3/4 of the way up, right? Almost 3/4. Not going to be super picky there. For future references, you're probably not going to graph this every time. But it'll be roughly about right there. And pi 6, is that bigger than pi fourths or smaller than pi fourths? Smaller, so that means like less than halfway. You could go up and make a point at about pi halves if you want to graph all of these. At 3 pi fourths, do you agree that's halfway between pi halves and pi? It's going to be also up there at that 0.71. 5 pi 6 is going to be a little bit closer to pi, and it's also going to be back there at 1/2. And then at pi, I go back to 0. What you should have made is somewhat of a nice little U shape, maybe. Upside down U shape. Now what's going to happen as we go down here? Should it be this exact same shape, only now everything's negative? Think about our values on the unit circle. They just change to negatives. So that's what's kind of nice about sine. Once you know what it's supposed to look like, you can do a bunch of things to it. But let's see here. 3 pi halves, I'm down here at -1. 7 pi 6 would be like -1/2, so that would be like somewhere around right there. 11 pi 6 would be over here close to 2 pi, also at -1/2. And at 2 pi, I go back to 0. And so what I kind of have is like a parabola on the top and then a parabola that comes up on the bottom. Sine is a smooth function. It's not jagged. It's not pointed. And what's really great is we could just keep going here, and this is just going to keep repeating itself. It's going to go up and then down, and then up and then down, and then up and then down, because that's what a periodic function does. It just keeps repeating itself. What's going to happen on the negative side here? We're going to think about our negative angles. Is it going to be the exact same? Like, am I going to have a parabola that goes up like this over here? What's going to happen? It's going to be the negative part, because do you agree at -pi halves is the same as +3 pi halves? Right? Because negative angles are going the opposite way. So the great thing about these is if you do the positive side, you already know the negative side. You just got to make sure you flip it. So at -pi halves, it's going to be down here at -1, because that's the same as 3 pi halves. And what about at -pi? Yeah, it's the same as pi. -pi and pi are the same. They're going to both be at 0. So I get the bottom half first. And then what happens at -3 pi halves? Yeah, those are the exact same angles, right? -pi halves is the exact same as pi halves, which means it goes up to 1. And at -2 pi, what happens? It goes back to 0. Could I plot all these points in the middle of that? I could. But I already kind of know what's going to happen. I know it's going to be that little parabola shape. So I'm just going to kind of make it. I'm just going to make this go down like this. And this go up like this. Look how cute that is. What if we talked about the domain and range of this? What would you say? The domain is going to be all real numbers, because notice it's a smooth curve. Remember that you could draw it without ever lifting your pencil up. It's going to be all real numbers. You could pick any angle you want. We just picked ones that worked out nice. What about the range of this? The highest that it ever is 1. The lowest that it ever is -1. -1 to 1. We could also say, and we'll come back to this more later, but sine, we talked about this the other day, is an odd function, which means this side is the exact opposite of this side. Do you agree that that's true? Every time that works on odd functions. So that's another way to help you. If you do this side will always just be the exact opposite. So you know it goes for sure. How about cosine? Let's do the same thing. That's the next section. We're going to spend a few days on sine and cosine. We're going to maybe not pick so many points on this one, just because I feel like we could pick lots of points, but if we can just pick some ones that work out really nice and see what's happening, I call them key points. Pick points that give you good points to graph, like 0. So now we're doing y equals cosine of whatever angle we're picking, right? So all what's changing on this one is now we're doing cosine, so our y values are definitely going to change. What do I get? What is the cosine of 0? What about if I just skip 2 pi halves? Do you agree that pi halves is going to give me a good number for cosine? What do I get for the cosine of pi halves? Yeah, my cosine is the x-coordinate, so at pi halves, it's 0. What would be another good point? Pi is a great point to pick. And if I pick pi, cosine of pi, it's over there on the negative side, so that's going to be -1. What do you think my next point is I'm going to pick? 3 pi halves. And when I go down to 3 pi halves, what happens to my x-coordinate? It's back to 0. And I'm going to go all the way around the circle and end at 2 pi. And what's going to happen here? Back to 1. Once you get back to 1, that means you've completed that one entire period, and we're going to talk about that again. But that means I've went all the way around the circle. So I'm going to make my x-axis the same way I did on the last one. I'm going to make this 2 pi. Halfway in the middle, I'm going to make pi. Half of pi is pi halves. And that would be 3 pi halves. It's not better than picking all those other points. I'm going to do the same thing over here for my negative values, doing the best I can to make this equally spaced, which sometimes doesn't work out so well. Do you agree my y-axis still only needs to go from 1 to -1? This cosine never gets bigger than 1, smaller than -1. Let's see if we just graph these 5 points, if we feel confident enough in sketching that graph. At 0, it's up here at 1. At pi halves, it goes back to 0. At pi, it goes down to -1. At 3 pi halves, it goes back to 0. And at 2 pi, it goes back up there to 1. Using the idea that sine and cosine are both smooth, continuous functions, not jagged, pointy edges, could you connect that and without picking more points? I think it's going to kind of look like this, like it's going to come down, and it's going to curve, not point, and go back up. Kind of like that, kind of like a big U, sort of. Could I be much more accurate by picking 1,000,000 points? I could, but that gives you a general shape, right? We got the negative side, yes, we got to figure that out. I do want to point out, cosine's never going to get bigger than 1, so if you're putting an arrow on this, you better make that arrow turn and go back down, because it's never going to go up, because it can't be bigger than 1. What's going to happen on the negative side? Is it going to be the exact opposite like the sine was, or do you think it's going to be the same? Remember we talked about cosine. Was cosine even or odd? Do you remember? Cosine is even, and if we think about this, at negative pi halves, do you agree that that's still going to be at 0? Like if negative pi halves, if I go back this way, I'm still going to have a 0 value. And at negative pi, do you agree that negative pi is the same as positive pi, and it's still going to be -1? Oh, no, sorry, positive 1. No, wait, what am I doing? -1. Yes. And -3 pi halves, is that still going to be a y value of 0, because it's still on the y-axis? X value of 0. And at -2 pi, I'm still going to be in the same spot, and I'm still going to get 1. Or if you just remember that cosine is even, like a parabola, whatever's on this side, it's the same thing over here, which is why I love even functions. Because it's like I get points for free. So that one right there, even function. The domain of this is going to be what? Also all real numbers. The range of this is going to be what? Negative 1 to 1. Sine and cosine are very similar. It's nice that you have those right next to each other, unlike my paper. Big differences to notice. Sine starts at 0, like 0, 0. Cosine always starts up here at 1, because at 0, the x is 1, the y is 0, so that's a big difference. But notice, they're both wavy. When you're graphing these, which you're not graphing much today, I say use these key points. Key points. Pick numbers that give you 0 and 1 and negative 1. Which means pick numbers that give you on the x and the y axis. Those are our favorite points to pick. You can pick whatever you want, but those are going to be the easiest ones to pick. So just like everything else we've done, today's big focus, we're not doing as much graphing today as we're going to do on the next day. Today's big focus is how can we translate these, right? We can stretch, we can shrink, we can move them left, we can move them right, we can move them up, we can move them down. What do you think is going to happen if I multiply a number out in front of that? Yeah. So I wrote we could graph both of these. Cosine of x is the same one we did. So you should be able to do that pretty quickly. I'm just going to make my graph here. 2 pi, pi, pi halves, 3 pi halves. I'm going to have to make an extra markup here now, I think. I'm going to graph cosine kind of in black behind here, the same way that we just did it. Picking those same 5 points, I'm not going to really waste a lot of time on doing again because we just did it. But I just want to see the difference between these. So at 0, I know that cosine is going to be at 1. And then it goes back to 0. And then to negative 1. Then back to 0. And then up to 1. Right? Just like we just did. Oh, wait, that should be up here. Right, that's what I call the parent function, the one that you should be able to use that to base all your other ones off of. We can make an XY chart for this one. Can I still pick my same points? 0, pi halves, pi, 3 pi halves, 2 pi. Are those still going to give me really good points? Yeah, because if nothing's changed here with the x, pick those points every time. If I pick 0, I'm going to get 2 times the cosine of 0. And what is the cosine of 0? 1, but now there's a number in front. 1 times 2, you're going to get a value of 2 instead of a value of 1. What about when I plug pi halves in? What's the cosine of pi halves? 0. So what's 0 times 2? It's still going to be 0. Again, we got to hopefully get feeling better about these values here. Pi, cosine of pi, negative 1. Negative 1 times 2 is negative 2. 3 pi halves, I'm back to 0. I go to 2 pi, I'm back to the same spot as I was at 0. So notice, all we've done is stretch that by a factor of 2. So when I graph this, it's still that wave, but now I've changed it to go from 2 to negative 2. The majority of your homework today says describe what's happening in the graph. Like describe how it's changing. Like on this one, you would say it's stretched by a factor of 2. The nice thing is, if you remember all the rules for transformations for other functions, it hasn't changed for sine and cosine. It's still the same kind of thing. So it's still that kind of W shape, only now we've stretched it out. The bigger the number here, the more stretched that it could be. Yes? No? Maybe? All right, and this is in your book. Also, I wrote it out for you, but these are the general forms of sine and cosine. I put lots of letters in here, but it's the same thing that we've done before. A number multiplied in front of your function is always going to be a stretch or a shrink. If the number's bigger than 1, like 2, it's going to stretch it out. If the number in front of it's a fraction, like 1/3, that's going to shrink that graph down and make it look a lot smaller. We could go through a lot of these. What's going to happen when the number's added outside? What's that going to do? If a number's added or subtracted outside of the function, what does that do? Yeah, it moves it up or down, which is the same thing that's going to happen to this. We're not really going to have any of those today, but that is what's going to happen. The inside stuff, that's really going to change our graphs for us, the trig functions, like moving it left or right. It's going to really change things for us. What else do I have on here? You agree that whatever number's in front is going to affect what your range is going to be on your graph? Like on the last one, that 2 was in front, did our range change from 2 to negative 2? Yes, no, maybe. Stretch or shrink, it's always what it is. In trig functions, we have a special name for that stretch or shrink. We call that the amplitude of the graph. The amplitude will always be how high and low your graph goes, or they describe that as half the distance between the maximum and the minimum. Between the highest and the lowest point. Do you agree with that? No, well, what would be the... No, if it goes up to 2 and down to negative 2, what's half the distance between that? Well, that would be the halfway point, but don't you agree that would be a distance of 2, and that would be a distance of 2? You see what I'm saying? I say, that's the book's definition. I always just say the amplitude is whatever number's in front, the absolute value of it. A couple more things. I know Bell's about to ready in a second. If there's a negative in front, just like always, a negative means it's going to flip it over, so it's going to reflect it. And the one thing that we really aren't getting to today is the period. The period could change, and so maybe kind of look at that tonight as you're starting your homework. But just so you know, before you run away here,
I need my students' office, please. I need Katie Moreland.
there are only 2 on your homework that you have to graph. The rest of them are just describing what's happening. Is it a stretch? Is it a shrink?
Thompson,
Maybe just recognize if the period is changing. We'll talk about that tomorrow.
Audrey Nichols, Austin Bromley, Carly Nichols, Rebecca Hazlett.